Microsoft Excel worksheets are very well suited to performing Bayesian analysis. In this movie, I will show you how to implement our analysis of the Kahneman's-Cabs problem. My sample file is 0704 calculating, and you can find it in the Chapter 7 folder of the exercise files collection. We've gone through the parameters of the problem several times in this chapter, so I'll just go ahead and start entering in the values and formulas. In cell B3, we need to establish the base rate of green cabs, and that is 85%. So in cell B3, I will type 85, and I've already formatted the cell with a percentage format, so I'll just press enter. You don't need to type in the percent sign. And in B4, I'll type the accuracy, and remember that the court established that the witnesses were accurate 80% of the time. So 80 and enter. Now we can find the probability a cab is green or blue, and then the probability the witness is correct or incorrect. So in B6, we need the probability that the cab is actually green. So I'll type an equal sign, and that will be equal to B3, which is the base rate for green. The probability the cab is blue is 1 minus the probability it's green. So in B7, I'll type equal, 1 minus B3, and enter. And 85 plus 15 is 100, so I know that those formulas are correct. Now we can do the same for the witness being correct or incorrect. So in B9, I'll type equal, and their accuracy is 80%. That's in B4, enter. And then in B10, probability they are incorrect, so equal, 1 minus the probability they're correct. That's in B4, enter, and we get 20%, and 80 plus 20 is 100. We can now use those probabilities to find the probability of a particular scenario happening, and we'll do that over here in our classification matrix. In cell E4, I want to know the probability that a cab is reported green when it's actually green. So type an equal sign, and the probability a cab is green is in B6, and we'll multiply that by the case where the witness is correct, and that's in B9, and enter. Now in E5, we need to know the probability that the cab is actually blue, but was reported as being green. So type equal, and then the cab is actually blue, so that's in B7, the probability of it being blue, multiplied by the probability that the witness is incorrect, and that's in B10, and enter, and I get 3%. Same thing for the cab being reported as blue. So in F4, I'll type equal. In this case, the cab is actually green, and that is in cell B6. And we'll multiply that by the probability that the witness is incorrect. That's in B10, and we get 17%. And finally, we want to find the probability of the case where the cab is blue and is reported as blue. So in F5, I'll type equal. The probability it's blue is in B7, multiplied by the probability the witness is correct. That's in B9, enter, and we get 12%. One way to check to make sure that your classification matrix has been done correctly is that you can add the probability of correct guesses. So we have 68 and 12, that's 80%, which equals the accuracy. And then inaccurate guesses, 17 plus 3 is 20%, which is also the probability the witness is incorrect. Now we can perform calculations to find the probability the cab is green when reported green and the probability the cab is blue when reported blue. So in cell E8, we need to type an equal sign and then find the number of times that a cab is correctly reported as being green, and that is in cell E4. And we need to divide that by the total number of times that the cab is reported as being green, even if it's actually blue. So after the division sign, I'll type a left parentheses, and we'll have E4 plus E5, right parentheses, and tab, and we'll see that that percentage, or probability, is 96%. Now we can perform the calculation that we did in previous movies as part of the example, and find the probability the cab is blue when it's reported blue. So in F8, I'll type equal, and the probability that the cab is actually blue and is reported as blue is in cell F5. It can be very easy to use F4 as your basis, but remember that that is an incorrect guess. So now we have the number of times that the cab is correctly reported as being blue, and we need to divide that by the total number of times it is reported as being blue, both right and wrong. So left parentheses, F4, plus F5, right parentheses, and enter, and we get 41%, which is the value that we saw earlier in this chapter.